popularity. And when I say that, people are always really, really surprised. What do you mean by that? That's kind of crazy. Why Twinkies? You say, well, flip the back of the box of a package of Twinkies. It has an ingredients list on it. It tells you what's in it. Does your software tell you what's in it? No, but it could, right? And one of the things that's always surprising to people is in this little treat, it has beef fat. So it's not safe for vegetarians. And people are always surprised. Why does a Twinkie, why does this junk food have beef fat in it? Well, that's one of the things that makes it so delicious. I don't know what to tell you. It also has a statement on it that says what allergens it contains. So if you're allergic to something, you can avoid that particular food. So if you're allergic to wheat, to egg, to milk, and soy, sorry, Twinkies might not be for you. And then it has a specific lot number. The date, the manufacturing line that these came off of is encoded in a number that then if the company that makes Twinkies finds out that maybe that line did something wrong and there's something amiss with that particular batch of Twinkies, they can do a recall. They can pull it off the shelves. They can fix it, replace it with one that's not tainted. And we have something similar in software and in technology. It's called a software bill of materials. And this is drawing again on these supply chain principles. In the automotive industry, between the 1970s and the 1990s, there was a revolution where we were able to track specifically the bill of materials to know what's in it. Now, in software, this might be something that says, you're using Apache Struts version 1.3.5. And so then you can know when a new vulnerability is discovered in Apache Struts 1.3.5, you can go and update that software really, really quickly without having to do a search, without having to try and figure it out, without having your customers call you and say, hey, did you know that you have this and it's vulnerable? You can just automatically do it. As the buyer, you can get this software bill of materials and you can analyze it. There are tools that will go through the hundreds or thousands of lines of a software bill of materials and say, these are the vulnerable versions, so that you can, like the Twinkie company, go and get those out of the product and replace it with something better. Next, junk food has an expiration date. So Twinkies have an expiration date. They won't be around in 100 years, tasting just the same. Many of these expiration dates mean it goes bad, but also some of them mean we can't really trust it. We don't really know that it's going to taste as good as it did when it came out of the manufacturing plant. And software can have this too. It's the supported lifetime. For how long will this particular box of Twinkies be warranted by the manufacturer to be just as gooey and delicious as it was when it originally came out? And a lot of software manufacturers and device manufacturers today are including these support lifetimes on their products. So if you look at, for instance, Microsoft Windows announces the minimum supported lifetime for their software when they put it out there. So they say it'll be good until 2029, January 3rd, for instance. And then they can extend that, but that's a minimum commitment. It's a minimum guarantee. And this is increasingly prevalent as we look for this type of technology to have the ability to update itself. We have an expression in the US and in English, we say something ages like cheese. That means it becomes bad over time. It molds, it changes. And I like cheese, but I also recognize that it is a case where the cheese in your refrigerator goes bad after a certain date, unless you're taking care of it, unless you're maintaining it. Software is the same way. So over time, it goes bad without regular care and maintenance. The next thing a Twinkie has is it has a serving suggestion on it and how to consume it. So this one says, remove wrapper before eating. Now, if you've never eaten a Twinkie before, you probably can figure out that you take the plastic off. If not, that first bite is going to taste real bad, I promise you. And you'll figure that out quickly enough. But some things have these serving suggestions on them, like, put it in the microwave for 30 seconds. Great, cool, that's delicious. You just helped me figure out a better way to eat a Twinkie. And this is the shared responsibility that we have between the manufacturers of that technology and the operators, the buyers of that technology. to be able to use it in the best way possible. These may be instructions for use, but they delineate what's expected from the manufacturer, what the buyer can expect, and what the manufacturer expects of that operator. Here's how to keep it updated. Here's how to maintain it. Here's how to ensure that it stays configured in a secure way. And then finally, at the bottom, it says, if you find something wrong with this box, maybe it's been opened, or maybe you find that it went bad before its expiration date, you can call the manufacturer, you can tell them about it, and they'll, in many cases, replace it. And this is similar to Coordinated Vulnerability Disclosure Program. How many people have heard of Coordinated Vulnerability Disclosure? What about bug bounties? Have you heard of bug bounties? Yeah, a couple of people. Good. So Coordinated Vulnerability Disclosure is kind of like the see something, say something for software and cybersecurity. If you notice that a bridge on your way to class is starting to collapse, you're going to want to call somebody and tell them. What if you find a flaw in software intentionally, maybe you're looking for it, or maybe accidentally you just happen to be using that software? Shouldn't you also have the ability to call that manufacturer and report that there is a safety issue, a security issue, something that could cause people to come to harm? And the answer is increasingly yes. Most companies today are starting to deploy these coordinated vulnerability disclosure policies that says, at a minimum, if you find something and you tell us, we won't sue you. We'll take your report, we'll investigate it, and we'll issue an update if we can, some type of a software update. And some companies who run bug bounties actually pay people. Hey, if you find something in our software, we'll give you money for that. And so that can be a really, really cool way to lawfully do security research in a way that also helps people. Okay, so if all of this is on the back of a Twinkie box, shouldn't we expect that that is in the things that we buy, in the cars that we buy, in my oven that's always connected and I can, from here, turn it on? Well, I think we should. And if you're making these new pieces of technology, if you're building this software, if you're starting a company or working for a company, shouldn't you offer the same things to your customers, to the people who are buying it from you, to the people who are trusting you with your responsibility that comes with that great power? I think the answer to both of those questions is that you should expect this, and you should expect to build it into your products. Okay, so let's talk about operational excellence, the second pillar, just a little bit. So how many people here have heard of Google? Okay, that's good. That was a test to make sure that people have arms and that they're paying attention. Many, many people in this room either don't have arms or they're not paying attention. But Google is a search engine for the world's information. How many people have heard of Shodan? A few people, great. So Shodan searches for things that might not have information that Google cares about indexing. It searches for servers that are online. In those servers, it searches for software that they're running, for versions of software, for default passwords, for vulnerabilities. So it has a lot of rich information. And so right now, if I wanted to say, look for power plants around the world that are running vulnerable versions of a software package that I could exploit, I can search Shodan for that. And it's kind of crazy easy to find these things. So one of the things that when I was at the Cybersecurity and Infrastructure Security Agency, the US government, that we built is this program called Get Your Stuff Off Search. It's how do you know what's on Shodan? How do you know what's on these other internet search engines so that you can either get them off the internet if they shouldn't be there? You know, my connected oven should not be directly connected to the internet so that anybody can turn it on and off. And how can you get it out of Shodan, out of these internet search engines? Because those are tools that adversaries use. They don't want to scan the whole internet. That's noisy. That takes up a lot of resources. It takes a long time. But if they can go to Shodan or one of these other websites and just see what's online, then that makes it really, really easy for them to carry out the next step of an attack. So get your stuff off search. Next is bad practices. And again, this is something that I developed when I was at CISA. The idea was there's hundreds of different standards for cybersecurity. Everybody has a different idea of what they think the best practice is, of how to really set a high bar for cybersecurity. But sometimes they conflict with each other. And there's thousands and thousands of different things and different variations on different things. So it becomes unwieldy to try and comply with all of the best practices. But can we at least agree what not to do? So we sat down and we figured out what things reliably fail. If you do these things, you're going to get hacked in probably 15 minutes. And that was a surprisingly short list. And so it can tell you start with these things. If you can at least do these things, then you can build some time in so that you can work on the thousands of other things that you might want to do. And those three things are fairly simple. And they're also things that you can use in your everyday life. So bad practices are unsupported or end-of-life operating systems. This is technology that is no longer supported. You can no longer get patches for it. So if there's a new vulnerability discovered and you're running supported software, well, the fix for it might take you a day. That's fairly quick. If you're running an unsupported operating system, you might never be able to apply that fix. And that's orders of magnitude worse security posture. The second one is using known, fixed, or default credentials or passwords. One of the most common ways that breaches happen, that intrusions happen, is through password issues. Oftentimes it's finding that somebody in your organization is using the same password on a critical piece of equipment that is accessible from the internet as they're using in an account that got compromised. Maybe one of those that I showed at the very beginning. Another way is through guessing default passwords. Password is a terrible password, as it turns out. Hopefully nobody uses password as a password, but if you do, you might not want to use it in some place that's really highly critical. And then third is single factor authentication for administrative and remote access. This is another bad practice. If you have remote capabilities to do something with high levels of access, you should secure that with a second factor of authentication. That can be a token, that can be a one-time password that comes to your phone, that can be an authenticator app. How many people use password managers, password management software? Awesome. I love password managers. You know why? So much easier to use a password manager to automatically log me in than it is for me to type that out by myself. That's such a pain. You know, even if I use the same password on all of the websites, I still got to type that out. If I use a password manager, I just go to the website, fills it in for me, I click go. It's awesome. Now, it also happens to be highly secure. Allow me to create highly secure passwords, unique credentials for each website. And so I'm able to improve my security over what I would normally do. It also lets me spot phishing websites because it won't automatically fill that information in. And I can say, uh-oh, this probably isn't the Gmail site that I was looking for. It's probably not Grab. So I'm not going to log into it. And then turning on automatic updates. So manufacturers of software have gotten really good at creating updates once vulnerabilities, once security flaws are known, so that they can fix those flaws, so that they can inoculate everybody who uses that software. But not everybody turns on automatic updates so that it just happens in the background. When there's a new vulnerability discovered, when there's a new attack going around, you're in a foot race against the adversaries to get your stuff updated before they can attack it. One of the best ways to do that is to get that fix before they can hit you, to get it as soon as possible, as far left in the timeline as you possibly can. And turning on automatic updates, whether it's on your phone, whether it's on your laptop, whether it's in your corporate environment, is one of the best ways to do that. Many, many companies have gotten really good at creating software updates that are entirely transparent, that maybe don't require a reboot. that are really well made, and so they don't cause any types of disruption. So turning on automatic updates can dramatically improve your security posture. And with that, I am done with my formal remarks, and I would love to get any questions, feedback, comments from anybody here.
All right. Thank you, Bo, for the great lecture. So please, if you have any questions, I saw one over there, perhaps three. Another one? Okay, Abid, please.
Should I introduce myself too? Okay. So my name is Abid Hermawan. I'm from the informatics department of ITS. I would like to ask. So you said that companies should explicitly say what technologies do they use, right? So if I were to say build a website using an Nginx server, or maybe use a service from uh, something like a Squarespace, I would disclose that. Uh, but what? So how how is it for the companies that are using their own technologies? They don't have the luxury to disclose what they're using sometimes, right? They have an NDA attached. They are probably still doing it, still have a prototype, not for public. And so what can they do to uh, basically uh, allow for people to easily check their products and stuff. Because if, like, say I have a Linux, right? It's open source. Everyone can check it. But how about for closed source software that are secret in nature?
Yeah.
Thank you.
It's a good question. It's a really common question among companies as well. The idea that some of the technology that you're using might be proprietary, it might be governed by non-disclosure agreements, it might be an internal thing. That can all be true. At the same time, if an adversary wants to know what's in your software, they'll just run it through IDA Pro, they'll decompile it, they'll look at all the packages, all the dependencies, so they'll have access to that. So why should defenders not also have the ability to see it? Secondly, if you're building some technology, you have to internally account for what's in it, right? I mean, DevSecOps principles, you got to know what you have to defend to be able to defend it. You've got to know what you have that you're building on to be able to update it. And so one of the things that I've found is when I ask companies about a software bill of materials, they privately tell me, well, we don't actually know what's in our software anymore. It was written 10 years ago by somebody who left the company. And now, like, how do we support that? But don't tell anybody this, right? It's like a big secret in software. But I think that, probably among this group, the people who are developing software understand that modern development principles require that you have this anyways. I also sometimes hear from people that, oh, isn't that a roadmap for the attackers? It's like, well, kind of, but also the attackers don't need a roadmap. They're attacking everything all the time. They're able to peel into that software using tools that will show them what's in it. So if I buy a piece of software to use it in my product, and there's an NDA saying that I can't look at it and see what's in it, then the business contract, the business relationship has put me at a distinct disadvantage. And so in the United States right now, there are new laws, new requirements that all software sold to the federal government, all software in medical devices, all software in aerospace, in these high-risk areas must disclose what's in it through a software bill of materials that says, here's the software package, here's the version of it, here's the manufacturer, and some other details that help, but just really, really basic, not anything that divulges intellectual property. And in the case of open source, a lot of times manufacturers are required under the license of that open source to disclose that they're using it. So it's actually the opposite of that situation with some of the closed source where they're required to tell people that they're using it. Another dirty secret of the software industry is that they don't tell people that they're using the software because they're violating license agreements. So there are many things like that that you know, hopefully by the time you get out and you graduate and you're in the industry developing, some of those bad practices will be fixed by then. If not, then you can certainly try and fix them and work to be better.
Right. Follow-up questions? Okay.
Last question for me. So what you're saying is basically try to disclose as much as possible, right? But for those, but if I were to do, like I said again, if I were to develop my own technologies, right? Should I at least disclose? Should I at least like share some of the things that makes that technology works, or should I keep it secret and just let people dissect it by themselves, or you know?
Yeah, it's a good question. It's a dilemma. How many people have heard of Kirchhoff's principle? Okay, so Kirchhoff's principle is the principle that when you develop a system, a measure of its security is your ability to disclose everything about the system except for a very few secrets, keys, for instance, credentials, passwords. And while that was originally intended for crypto systems, it applies more generally and more broadly. So in 2016, 2017, I was at an automotive security event, and one of the automakers was on stage talking about their security program, and they couldn't say much because, you know, it's top secret stuff. Like, we're really, really good at this. But if we told you anything about how we do it, of course you could break it. That's not really confidence inspiring, is it? That says maybe you didn't do such a good job that you thought you did. Now, to their credit, this same auto manufacturer, 2 years later at the similar event, open sourced their entire security model for their cars. They had this realization that actually, by opening it and exposing it, they're allowing people to help them make it better. They're showing that you can trust it because we can expose this. And now they kept those secrets very, very secret. Their key signing keys, for instance, kept very, very secret. But the architecture of it, they published it. And actually today there's a standard called AUTOSAR that is an open source security architecture for vehicles that most automakers are moving to because it has been vetted, because it's been beaten up on, because it's been understood so well by people. And so this is an example where openness and transparency leads to much greater security. And if you're building your own thing, I know the common approach is to kind of keep it secret because you've got a lot of hacked together code. You've got some things that maybe you're not so proud of how you did it. That can be okay, but understand that a more open system tends to be, other things being equal, a more secure, securable system, which is why for cryptography, all of the cryptographic design and architecture is published. It's peer reviewed by mathematicians and by others to be able to look at it and say, yep, we know that we can trust this because it's been exposed to the light of day. So thank you. Very good questions.
Thank you very much. Okay, so next question.
Please allow me to introduce myself, sir. My name is Muhammad Abdul Rafi. I am from the informatics department of ITES. And my question is about passwords and credentials. Usually all of us around here, we tend to reuse the same passwords. That's because, yeah, we suck at memorizing passwords.
Passwords suck. It's not you, it's the passwords that suck.
So how is it that we can keep our passwords secure, and how is it that these passwords managers really work? That's because we don't like making a lot of different passwords, and even sometimes Google offers to make random passwords, but we can't even remember them, and we want to be quick when inputting passwords and other credentials and accessing sites. So how is it that these password managers work, and are there anything that we can do to make our passwords more secureable and more safe? Thank you.
It's a great question. I hate passwords. Passwords are terrible. It's a 70 year, actually, it's more than 70. It's 70 years old in computing technology just because computing has been around for 70 years. But has anybody heard of the story of Alibaba and the 40 Thieves out of 1001 Arabian Nights? Anybody seen the movie Aladdin? Okay. Based on the same story. What's the inciting incident in Alibaba? What's the inciting incident in Aladdin? A shared secret that gets you into a cave of wonders. For thousands of years, we've known that passwords suck, but we're reluctant to change them because, I don't know, inertia. So I would like to see a future without passwords, where we have maybe biometrics, maybe some type of memorized thing, where we have tokens that you can use. There's three types of credentials. There's what you know, what you have, and what you are. What you know is like a password. And so we've used those forever and ever because our memory is generally pretty good if we can remember one thing. But when you have 1,000 different systems to log into, that type of credential is no longer going to survive. The what you have is things like tokens. So has anybody heard of like YubiKey or Google Titan Key? Yeah, great. So these are really, really high security things. They're mathematically provable with their crypto systems. They're incredible pieces of technology that you can buy for like $25, or in some cases, some companies will give them to you that provide a very high assurance that if you are the holder of that token, you can't duplicate that token. And then the third one is what you are. This is biometrics. It's your fingerprint, it's a retina scan, it's your face ID. It's any of these things that are increasingly becoming prevalent and prominent. And there's many, many other biometrics that you could use. So ideally, you want a credential system that has at least two of those types of factors. So the most common one is a password and a token. It's something you know and something you have. That's not the answer you asked for. For password managers, how they work is that they will have a database that's stored locally on your computer, or in some cases stored in the cloud, that will be able to generate really strong passwords and keep those passwords for you. And then they have a browser extension that every time you go to a website, whether it's on your desktop, your laptop, or on your phone, they will auto-populate your information. Or if you have multiple accounts on a site, they'll let you select which one you auto-populate. And so when I pull up a new website, the password manager pops up and says, which account do you want to use? I touch the screen, it fills it in, I click log in, and I'm done. I don't have to remember passwords because passwords suck. Once every 2 weeks, it asks me for my primary password for the password vault. So I do have to remember one password, but you're already remembering one password. And so that makes it even easier to use. Now, there are many, many different types of password managers, or many different brands of password managers. Some of them are free. There's one called Bitwarden that I really, really like. It's free and it's open source. So if you want to run through the code and inspect it and make sure it's doing what it's supposed to be doing, you can see for yourself. There's other ones that have commercial versions that you can pay for your whole family. If you're like me and you're IT for your entire family, those can be a really good way to help people avoid get their account taken over. How many people here have had family members or friends that have had their accounts taken over? Yeah, it's a very, very common thing. Well, this can help that. Now, how many people, when their friends' accounts are taken over, do they call you and say, help, my account's been hacked. Can you get it back for me? Well, imagine if you never had to have that phone call again. Wouldn't that be worth the price of recommending a free password manager? It has been for me. Okay, next question.
Right. Thank you. Do you have any follow-up question? Okay. No? Okay. Right. Another question? Yep.
Test, test. Okay. My name is Irul. I'm from the informatics department of ITS. I have a question regarding the security because nowadays it's the development towards AI, automated system. So like, how do we navigate this AI? Because in order to advance AI, we need to share the data. The AI needs our data. So like in our generation, how do we uh, like pick and choose to develop the AI? Because it needs our data, but we don't want our privacy to be uh, breached or something. Okay.
Yeah,
Thank you.
it's a great question. So artificial intelligence is software, it builds on other software. So in terms of security, all of the stuff that you have to do to secure regular computing systems, you have to do for AI, plus any AI specific security. So uh, where we're having troubles just solving the simple problems of security on the platforms that underlie it, that's problematic. Then when you add this other thing that we don't really understand very well, that increases the complexity of the security problems that we need to solve. So if anybody in here is looking for job security when you get out, AI security, that's a thing for you. Um, Earlier this year, I worked on a project for the US Federal Trade Commission around voice cloning. The idea being that people can use AI to sample your voice, for instance, and then play it back to your friends and say, "Hey, it's me. Give me $1,000 because I'm stuck in jail," or a common type of scam. Or more frequent is to call up your grandparents and say, "Hey, it's me. I'm stuck in jail," and they might pull your videos from TikTok, from Twitter, from wherever else you've posted these to get a cloning of your voice. It's a really, really serious problem. Beyond that, you also have issues like the use of creative information, like artwork, like literature, like other things, to train these models without the consent of the artists, the creative people who generated those. But then you have the people who are using AI like a new paintbrush to create wholly new works of art, wholly new art works of literature, wholly new works of images or audio, music. So one of the things that I think we're going to need to do in the future is to have multidisciplinary conversations. In Silicon Valley right now, and in a lot of places where they're inventing AI, it's just a bunch of technology dweebs like me who sit down and come up with this great idea and then put it into action. But they haven't really evaluated the societal consequences of that. They haven't thought about what does it mean to be an artist whose work is stolen and used somewhere else. In fact, it's funny to watch as AI takes the work of others, incorporates it into their own, and then sells it. And then when people use the output of that AI, they say, "You stole that from our technology." It's like, well, guys, do you not realize it's the same thing that's happening? So I don't think there's a fix for it or a solution for it right now. I think that we need to evolve that. And I think that we need to have some really, really hard conversations really soon before these models are trained, before it becomes too expensive to retrain them, to deploy new ones, because that's what's on the horizon. Already today, the costs of training some of these models are hundreds of millions of US dollars. That's just astronomical. And they're using limited data sets. So when we have expanded data sets, it's going to be even more and more cost to retrain these models. So hopefully that kind of answered your question. I don't have a good answer for it, unfortunately, but maybe you can find one.
Right. Any follow-up question? No? Okay. Another question? Oh, we have one at the back.
Okay, good morning, Mr. Woods. Let me introduce myself. I'm Cliff Sostastoma from Informatics in IDS. I don't really think it's kind of a cybersecurity question, but I'm kind of considering as it is because maybe some of us played games by Riot Games, for example, Valorant or League of Legends. And the news are that League of Legends are gonna implement the system of Riot Vanguard. And the way that Riot Vanguard works is that it scans through all your computer files and it just kind of checks if you are using cheats or not. And would you consider this as something dangerous, or would you just let it be? And if you think that this is dangerous, do you think that there's any other efficient ways where we can detect cheaters without scanning through all the files in their computers? Thank you.
Yeah, it's a good question. It's that type of approach has been around for many, many years of, well, we can't trust you on your computers, but we have to have root level access to your computers, everything that's happening on it. Well, that's a really brute force approach to the problem. And it's one that comes from many decisions that have been made over many, many years to have an open platform like a laptop, like a desktop, that allows any type of software to run, that has any software can reach out and inspect any other type of software, data, running algorithms. I got my start in hacking by trying to do cheats on the original Diablo back in 1996, 1997. So gaming cheats is something that got me really interested in security. Now those were all on my own computer. Back then, it didn't require an internet connection to play. The files were all save files. You can go in with a simple hex editor, like something like IDA Pro, and go in and tweak values. And then all of a sudden, you've got all the weapons in the game. You're invincible. You can just go up to Diablo and punch him once and he dies. It was a lot of fun, but only for a minute until you realize that playing games with cheat codes it's kind of boring. This is a very, very different computing environment, gaming environment. I think that the practice of putting cheat detection software, requiring this really invasive software in order to play a game, is not one that I would want to support or endorse. So I'm not going to play games that have that. But man, if you've already gotten into that ecosystem and you're really into it and that's a lot of fun for you, it's a hard decision to make. I think that ultimately it exacerbates the cat and mouse, the attack, counterattack that have been going on with cheaters for decades. It's just the latest escalation. I remember back in the early 2000s when Counter-Strike was developing some of its counter cheat mechanisms. There was a similar backlash when Sony had some software that would silently install in your computer so that you couldn't play music that wasn't licensed by Sony. Like that was a big deal too. I think that as these content creators, as these intellectual property rights owners try and protect their intellectual property, try and protect their revenue streams, we're going to have to find a better way than completely compromising the security of your computer and your computing model in order to preserve that. And I think that, interestingly enough, mobile games and the mobile platforms are actually highly secure, highly resistant to that type of thing, highly resistant to allowing cheats as well. So maybe one of the ways of the future is to actually, instead of undermining security, to improve security of your computing environment to a point where the cheats won't work in order to play games. So something more like the phone environment.
Right. Did I answer the question? Okay. Perhaps we can have time for one more question. Otherwise, I have a question myself. So lots of students here, they didn't know about cybersecurity before. And the most questions they asked to me is, how do we start getting into cybersecurity? Which learning pathway would you recommend? Which kind of book would you recommend? Those are the kind of questions that they usually ask. If you have any recommendations or suggestions to them.
Yeah. So I always recommend that people start with what they're curious about, start with what they're really passionate about, and then let that guide them. There's 100 different specialty fields in cybersecurity that you can pursue. Not all of them will be interesting to you. Not all of them will be fun for you, but some of them will just, you'll feel at home. You know, I remember when I started with cybersecurity and I went to events, I went to conferences, I did CTFs and other things. I was like, oh yeah, this is what I've been waiting for. This is the community I've been trying to find. And it really pulled me in, and it helped me develop my skills, develop my capabilities, develop my tradecraft and my ability to understand these cultures and understand what's right and wrong through doing that. As I understand it, there's CTFs that happen here. There's cybersecurity clubs here. Go sit in on one of those. See what happens. See what gets you really, really just so passionate about it that you can't not do it. And that's great. If you don't find anything that really draws you into cybersecurity, keep in mind that software development involves cybersecurity too, that chipset making involves cybersecurity too, that IT deployments involve cybersecurity as well. And try and integrate that into your IT career. You know, if you know a little bit more about cybersecurity than the next person, you will be by de facto in the office place your cybersecurity expert. That's what happened to me. I, you know, had made a lot of security mistakes on my own computer when I started working in IT. And all of a sudden, I got all the security cases, and I was able to build up my capabilities, my skill sets by learning, by expanding that. So find your own pathway, I think, is the best way I can say it. Because ultimately that's what's going to lead you to the highest level of satisfaction. It's going to lead you to the highest level of capabilities in that field if you're super interested in it, and if you actually want to do it and want to be there.
Right. Thank you. Perhaps one last question for me. So you're speaking about we should do automatic updates all the time with our operating system, but there has been some cases where if we update the system, it would break everything. Like for example, I think there's one server that has PHP 5, and then if you update the PHP to 7, not 8, the most recent one, it will break the website. It will break everything. So what would you recommend in that situation?
Yeah. Well, there's a concept called technical debt. And just like it is okay to incur a certain amount of debt, it can allow you to move faster. You have to pay down that debt at some point. And it sounds like your technical debt is overdue to call in that loan. But the the costs and the resources involved in redeveloping that in PHP 8 or in Python or in something more modern, more maintainable, more supportable can be quite expensive. And so this is a similar problem that a lot of organizations face, is how do you do that? As we talked about a little bit earlier, one of the books that I like to recommend is called The Phoenix Project. And there's also a companion book called The Unicorn Project, which was just released. And these are books about a transformation from an old broken system to a new, less costly, more supportable system while the organization was still operating the old system. So these things can be done. They're challenging. They take leadership commitment to it. They take an ability to weather some bumps and bruises along the pathway, because you will have those. But it is possible. And so, hopefully you can find a way to get to something where or as one of my friends sometimes says, you won't make changes until the pain of staying the same is greater than the pain of changing, and you might be getting there.
Right, that's a great quote then. Okay, thank you both for this great talk. I think before we close the talk and prepare for the Menti meetup.
Absolutely. So we're going to have a fun test. This will not be on your final exam for your classes, but it will be enjoyable. I've seen this system work, and it's always a lot of fun. And I can stand up here and narrate how this is going to work. So how many people are now going to go home and look at password managers? It seems like a lot of people. Yeah, like I said, my biggest breakthrough with password managers was not when I was like, oh, I have to be more secure. It was like, oh, wait a minute, I can be even lazier? This is awesome. So that was what transformed me in my journey to password managers. And there are several different ones that do different things that have different pricing models. You can look through them, and I actually have two or three that I tend to use just to see what's happening with the other ones, and maybe I'll change over to one of those. But um, they can be really, really good.
And I think you mentioned that you started from psychology, right?
Yeah.
Yeah, you did. So for me, it was the other way around because when I was doing my PhD, I was sick of my research and I started exploring other stuff, including psychology. And turns out that psychology is useful for cybersecurity as
Yeah.
well because you have to learn how people behave with the policy that you're implementing.
Yeah, and for me it was similar. I actually started out in computer science, and when I started learning how to program, most of my classmates had already been programming for a decade, and so they were way farther ahead of me. And I was like, "Well, I'm always going to be the worst person in the class. That sucks. What is something else that's actually fun and enjoyable that I can do?" And I found that I was just really curious and passionate about psychology. How do people's minds work? We're building artificial intelligence to simulate natural intelligence, but we don't really understand natural intelligence to begin with. So maybe let's start looking at that. I found that it was kind of cool to see how people work, what makes them tick, how they do certain things. And so it was really, really enjoyable. And then my first job was I was working IT in a hospital. So I can't escape the technology. It's just in my blood. But I think that cross-disciplinary focus, psychology and technology, have been really, really helpful for me in my cybersecurity journey. Okay, so we're almost ready with this. Hopefully this will be a good measure of what you learned. If we'll see if everybody gets the questions wrong, it means I taught it wrong. So, that's on me.
Right. Could you try to scan the QR code? Oh, yeah. And please write down your name. I'm gonna try it as well. Oh, click on the thumbs on the screen, on the screen. So if you logged in. Okay, the first question is, after learning about cybersecurity, I understand more.
All right, good. Looks like most people agree. One person has either no idea or you just thought that that GIF was really cute.
The people who answer no idea reminds me of the song by Radiohead, Creep. Okay, the next one. Uh, Hang on, it takes a while as well on my phone. The presenter hasn't changed slides, or oh, that's probably my
Cool,
connection.
sick. Hell yeah. In I'm surprised nobody has yet put Twinkie. Or at least I haven't seen it yet. It's not one of the top 5 answers, so I feel like I haven't done my job if you don't all go home and figure out what Twinkies are. This is the kind of high quality cultural exchange.
You
that
should
the
have
US embraces.
put Indomie instead of Twinkies, perhaps.
Oh yeah. Now we got Twinkies. All right.
Okay, this is the time to enter your name. Okay, connection matters, guys.
All right, let's see what we get here. Oh, all right. Yes.
Yes.
Half the people got it right. That's good. I mean, at least half of you were paying attention. I did my job well enough. We've got 140 people playing like this. Soon we're going to be League of Legends level. This is going to be amazing. All right.
Okay.
Just about everybody was paying attention. This is amazing. This is from one of the first slides. So if you've forgotten it by now, I'm not surprised. I've been talking for a long, long time. Oh, okay.
Oh.
Activists and cyber criminals, script kiddies. I think hacktivists was also a pretty good one there. We'll probably give it to you too. Oh, connection problems. Okay, here we go.
Profit would be the highest one. See?
It always is. College kids. But hey, everybody got it right. This is fantastic. All right, let's see who won. Ooh, all right. And then,
Okay.
all right, Glenn. Well done, Glenn.
Okay, Glenn. So for the top 5 people, please come forward, and we have some souvenir from the U.S. Consulate of China. So Glenn, where's Glenn?
Maybe Glenn's online.
Oh, that Glenn's over there. Please come forward. And then we have Danny. Danny with double N and Y. And then we have Muhammad Davin. Okay, we have the third place. And then we have Vinzario Santana. Okay. And then last person is Stephanus. Okay, so these are the top 5 from the quiz and get some souvenirs from the consulate. And for the people who asked the questions, excluding me, also get the souvenir. So please be ready to come forward after this. Congratulations. Congratulations, guys. Thank you for being the fastest and the most correct. Okay, so for people who has asked the questions, I think this one, a bit people at the back, I think there was five people. 5 people, please come forward. The people who asked the questions, where, so for, which one, the last one? 4 people? Oh yeah, excluding me then. So 4 people. Right. Okay, those were great questions from your friends here. And thanks to the US Consulate General in Surabaya for the souvenirs from one of our most active students. Okay, so before we close the sessions, perhaps I would like to sum up some parts from the talk. So we just had a guest lecture from Bo Woods, and some of the things that he talked about was the list of adversaries and the difference in the capabilities and the willingness to attack our systems. And then he also introduced us to the 5 P's frameworks that motivates some of us to become security researchers, from protectors, puzzlers, pride, payment, the most option picked, and protests or patriotisms. And then there's some information about the cyber hygiene hierarchy of needs from the bottom up, defensible infrastructures, IT operations excellence, and the countermeasures. And we also need to consider the supply chain in our software. You use libraries, your software depends on another piece of software that might be vulnerable. So that's one of the things that you have to consider. And we also have to remember that security is our shared responsibility. It's not just us as the security engineer that's responsible for the security of our system, but also the users, the developers, the UI designers, and the other people that involved in the company or institutions. And then we also have some bad practices like unsupported software, weak password, and using single factor authentications. And to cope with that, it is highly suggested to use password manager and do the automatic updates. I think that sums up the talk from today. And thank you again, Bo, for the great talk. I hope we meet again and we can collaborate in the near future. Right. Thank you, everyone, for coming. I think it's time to close this session right now. I'll give it back to the MC.
Okay, thank you before Mr. Baskoro and Mr. Bowoods for the amazing presentations. I think everyone is very happy today following the session, especially those who got the rewards, who got the presents. I think they're all happy. Okay, so ladies and gentlemen, we have finally arrived at the end of the session of this guest lecture series. We would like to sincerely apologize if there is any inconvenience we may have caused during this event. We also want to extend our gratitude to all of you for your active participation. Okay, ladies and gentlemen, esteemed guests and our wonderful participants, before we officially conclude this remarkable event, we'd like to take a moment to capture this special gathering. Please join us for a group photo to commemorate this event. So for all of you, maybe you can stand up and we can take a picture together. Okay, guys, maybe that is all from us. Once again, I would like to say thank you for your active participation. I would also like to say sorry if there's any inconvenience that we have made. Maybe that's all. Thank you for following us in this journey. Until next time, this is Angela signing off.